Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is DFA example problems. First one, draw a DFA for the language accepting strings ending with 0 over input alphabet 0, 1. Here the input alphabet is 0 and 1. Here the valid strings are any string combination of zeros and ones ends with 0. The last symbol must be 0. Before that we can have any combination of zeros and ones. Any ones, any zeros, any combination of zeros and ones. Last symbol must be 0. Invalid strings are if the last symbol is 1, that is invalid, and also this is valid, last symbol is 0, this is valid, last symbol is 0. You have to observe the first symbol either 0 or 1, either 0 or 1, last symbol must be 0. In between, before last symbol we can have any combination of zeros and ones. For that we need to draw the DFA. Q0 is the initial state. Initial state is represented with a circle, arrow, a small arrow coming towards the state. So we need to define transition function for every state and every input symbol in the DFA. For the Q0 is a state. For this state, we need to define a transition function for input 0 as well as input 1. So for example, the string may begin with 1 or may begin with 0. So that if the first input symbol is 0, I can go to final state as it may be last symbol. We assume that this symbol may be a last symbol, may not be last symbol. First symbol also may be 0, first symbol may be 1. In Q0, if you read 0, the machine will go to final state. In Q0, for input 1, stay in the same state. You can read as many number of ones as possible and stay in the same state. Whenever you read 0, I can go to final state. We assume that 0 may be last symbol, so that I can go to final state. In final state also, you need to define transition function for both inputs 0 and 1. Once you reach final state, if you read as many number of zeros, stay in the final state. In Q1, if you read 1 as input, that means if the last symbol is 0 only, you stay in the final state. If the last symbol is 1, you should not stay in the final state. So that in Q1, if you read 1, you should go to Q0. You should go to Q0. This is the transition diagram or state diagram. Transition table. Q0 is the initial state, Q1 is the final state. The inputs are 0s and 1, 0 and 1. Q0 on 0 going to Q1, Q0 on 1 going to Q0, Q1 on 0 going to Q1, Q1 on 1 going to Q0. Take a sample example. Initial state is Q0, 0, 1, 0 is the string, valid string. That means the string end with 0, 0 is the last symbol. Q0 on 0 going to Q1, so Q1. Remaining input is 1, 0. Next, Q1 on 1, Q1 on 1, Q1 on 1 going to Q0. Delta of Q0, Q1 on 1 going to Q0, remaining input is 0. Next, Q0 on 0, Q0 on 0 going to Q1. So, Q1 is the final state. Take another example string, invalid string. Q0 is the initial state. The machine is always stay in the initial state before processing the input. Take invalid string 1, 0, 1. 1 is the last symbol, that is invalid string. So, after reading this entire string 101, the machine will be in non-final state. Q0 on 1 going to Q0, remaining input 0 1. Q0 on 0 going to Q1, remaining input 1. Q1 on 1, Q1 on 1 going to Q0, Q1 on 1 going to Q0. Q0 is the non-final state. So, we define machine DFA M is Q sigma delta Q0 F. Q is set of states. Set of states are two states Q0 Q1. Sigma is input alphabet 0 comma 1. Delta is a transition function Q cross sigma to Q. Then Q0 is the initial state and F is the set of final state, only one final state Q1. This is the formal definition of the DFA. So, this is the answer for DFA for the language accepting strings ending with 0 over input alphabet 0 comma 1. Next, draw a DFA for the language accepting strings ending with 0 1 over input alphabets 0 comma 1. Here, the string should be end with 0 1. The last two symbols must be 0 1. Before that, we can have any combination of zeros and ones. Combination of zeros and ones. The last two symbols must be 0 1. That is order also important. 0 followed by 1. Last symbol is 1. Last but one symbol is 0. 1 0 0 1 is a valid. 1 0 0 1 0 1 is a valid. 1 1 1 1 0 1 is valid. Invalid strings are 0 0 0 0 is a invalid. Okay, invalid. 1 1 1 is invalid. 1 0 is invalid, like that. For that, we need to draw the DFA transition diagram. Initial state Q0. Q0. For Q0 in DFA, for every state and every input symbol, we need to define the transition. So, delta on Q0. Q0 on 0. Q0 input alphabet is 0 comma 1. So, Q0 on 0. Here, the last two symbols are 0 1. We need to find the prefixes. Prefixes of 0 1. This is the last two symbols are 0 1. Prefixes 0 1. Prefixes of 0 1 is 0 and 0 1. In Q0, if you read 0, that is prefix of 0 1. 0 is a prefix of 0 1. So, that I can go to Q1. So, in Q0, if you read 1, 1 is not prefix of 0 1. Stay in the same state. So, in Q1 also you need to define transition for 0 and 1. In Q1, if you read 0, stay in the same state because 0 is the prefix of 0 1. Q1 is meant for prefix 0. In Q1, if you read 1, that means previous symbol is 0, current symbol is 1, that is 0 1. 0 1 is prefix of 0 1, so that I can go to final state. Q2 is the final state. In Q2 also you need to define the transition function for 0 and 1. If you read 0 in Q2 in Q2 if you read 0, previous symbol is 1, current symbol is 0, that is 1 0. 1 0 is not prefix. If you read current symbol is 0 in Q2, if you read 0, that is current symbol, that is 0. 0 is prefix of 0 1, so that I can go to Q1 for 0. For 1, in Q2, if you read 1, previous symbol is 1, current symbol is 1, both are 1 1, that is 1 1 is not prefix, 1 is also not prefix, I can go to initial state. Once again, I have to find prefix 0 or prefix 0 1. This is the transition diagram for the strings ending with 0 1. Transition table. Q0 is the initial state, inputs are 0 and 1, Q0 on 0 going to Q1, Q0 on 1 going to Q0, Q1 on 0 going to Q1, Q1 on 1 going to Q2, Q2 on 0 going to Q1, Q2 on 1 going to Q0. Q0 is the initial state, Q2 is the final state. DFA M is equals to Q sigma delta Q0 F. Q is set of states Q0, Q1, Q2, 3 set of states. Sigma is 0, 1. Delta is a transition function Q cross sigma to Q, and Q0 is the initial state. Then final state. F is set of final state. Q2 is the only final state. Next, draw a DFA for the language accepting strings ending with 0, 0 over the input alphabet 0, 1. Input alphabet is 0, 1. The last two symbols are 0, 0. Before that, we can have combination of zeros and ones. Valid strings 1, 0, 0 is a valid, 1, 1, 1, 1, 0, 0 is a valid, 0, 0, 0 is a valid, like that. Last two symbols are 0, 0. Invalid. 1, 0, 1 is invalid, 1, 1, 1, 0 is invalid, 1, 1, 0, 0, 1 is invalid. So, these are invalid strings. See, last two symbols are 0, 0. Initial state is Q0. Initial state is Q0. Prefixes of 0, 0 is 0 and 0, 0. Q0 and 0 going to Q1 because 0 is prefix. Next, Q0 and 1 stay in the same state because 1 is not prefix of 0, 0. In Q1, you have to define transition for 0 and 1. Q0, in Q1, if you read 0, that is previous symbol is 0, current symbol is 0, that is 0, 0. 0, 0 is a prefix of 0, 0. I can go to final state Q2. Then in Q1, if you read 1, that is 1 is not prefix of 0, 0 and previous symbol is 0, current symbol is 1, that is 0, 1 is not also prefix of 0, 0. So, that I can go to, I have to go to previous state for 1. In Q2, if you read 0, previous symbol is 0, current symbol is 0, that is 0, 0 is prefix of 0, 0. So, that I stay in the same state. Then in Q2, if you read 1, I should not stay in Q2, that is the current symbol is 1, that 1 is not prefix, 0, 1, previous symbol is 0, current symbol is 1, that is 0, 1 is not prefix of 0, 0. So, that I should go back to initial state for 1. This is the transition diagram for the language accepting strings ending with 0, 0. Transition table, Q0 is the initial state, Q1, Q2 is the final state. Q0 on 0 going to Q1, Q0 on 1, Q0, Q1 on 0, Q2, Q1 on 1, Q0, Q2 on 0, Q2, Q2 on 1, Q0. So, next, this is the answer for the given question. Next, draw DFA for the language accepting strings ending with 0, 1, 1 over the input alphabet 0, 1. Input alphabet 0, 1. The string should end with 0, 1, 1. Last three symbols must be 0, 1, 1. Last symbol is 1. Last but 1 is 1. Third symbol from the right hand is 0. Remaining is combination of zeros and ones. So, valid strings, last three symbols are 0, 1, 1 is valid, invalid are invalid, like that. These are the invalid strings. For that, we need to draw the transition diagram. Q0 is the initial state. So, prefixes of 0, 1, 1 are prefixes 1, 1 are 0, 0, 1, 0, 1, 1. So, if you read 0, I can go to Q1. In Q0, if you read 1, stay in the same state. 1 is not prefix of 0, 1, 1. 0 is a prefix of 0, 1, 1. So, that I can go to Q1 for 0. In Q1 also, if you read 0, stay in the same state because 0 is prefix of 0, 1, 1. but previous symbol is 0, current symbol is 0, that is 0 0 is not prefix, but 0 is only 0 is prefix of 0 1, so that stay in the same state. If you read 1, that is previous symbol is 0, current symbol is 1, that is 0 1, 0 1 is prefix of 0 1 1, so that I can go to next state Q2. In Q2, if you read 0, current symbol is 0, previous symbol is 1, that is 1 0. 1 0 is not prefix of 0 1 1. 0 is prefix of 0 1 1. So that in Q2, if you read 0, 0 is prefix of 0 1 1. So that I can go to Q1 for 0, because Q1 is meant for prefix of 0. If you read 1 in Q2, I can go to final state, because I have seen last 3 symbols as 0 1 1, like this path 0 1 1, or this path 0 1 1, or this path 0 1 1. So last 3 symbols are 0 1 1. This is the Q3 is the final state. In Q3 final state, if you read 0, 0 is the prefix of 0 1 1, but previous symbol is 1, current symbol is 0, that is 1 0. 1 0 is not prefix of 0 1 1. So for 0, 0 is prefix, so that I can go to Q1, because Q1 is meant for prefix 0. Then if read 1 in Q3, 1 is not prefix of 0 1 1, so that I can go to initial state. This is the DFA transition diagram for the question having the DFA for the language accepting strings ending with 0 1 1 over the input alphabet 0 1. Next question, draw a DFA for the language accepting strings ending with 0 0 1 1 over the input alphabet 0 1. So 0 1 is the input alphabet, last 4 symbols 0 0 1 1. Before that we can have combination of zeros and ones. So prefixes of 0 0 1 1 are 0 0 0 0 0 1 0 0 1 1, 0 0 0 0 0 1 0 0 1 1 are the prefixes. So Q0 is the initial state. If you read 0, that is prefix of 0 0 1 1, I can go to Q1. If you read 1, stay in the same state. In Q1, if you read input symbol as 0, I can go to Q2, that is 0 0 is a prefix of 0 0 1. Then in Q1, if you read 1, 1 is not prefix of 0 0 1 1, so that you go back to initial state. In Q2, if you read 0, stay in the same state. 0 is the prefixes. See, previous symbol is 0, this is previous symbol is 0, current symbol is 0, that is 0 0 is prefix of 0 0 1 1, so that stay in the same state. If you read 1 in Q1, I can go to Q3, because last 3 symbols either this path 0 0 1 or this path 0 0 0. So in Q3 0 0 1 we have seen. In Q3 if you see one more 1, so that I can go to final state Q4. This is last 4 symbols are 0 0 1 1. In Q3 if you read 0, current symbol is in Q3, current symbol is 0, 0 is prefix of 0 0 1, previous symbol is 1, that is 1 0, 1 0 is not prefix, so that you should go back to Q1. See, from Q3, previous symbol is 1, current symbol is 0, 1 0 is not prefix, so that you should not stay here. If you read 0 here, Q3, 0 is the prefix, so I can go to Q1, that is 0, current symbol is 0, if the next symbol becomes 0, that is 0 0, after that you can get 1 1, I can go to final state. In Q4, if you read 0, that is 0 is prefix, so that I go back to Q1, 0, next 0, 1, 1 comes, I can go to final state. If 1 comes, 1 is not prefix of 0, 0, 1, 1, so that I should go back to initial state. This is the transition diagram for the DFA accepting strings ending with 0, 0, 1, 1. Thank you.